Hello and welcome to lesson 4.3, how derivatives affect the shape of a graph. We're going to be looking today at how you can use a derivative to tell what an original function is doing in a graph. Is it increasing, decreasing, where's a maximum, minimum occurring, and to look at concavity. So first, a reflection here, increasing, decreasing functions. Hopefully you remember that f is increasing from a to b if every subsequent y is larger as x gets larger. So you can see here from a to b, f would be increasing. Here. F is decreasing from b to c if every subsequent y gets smaller as x gets larger. So from b to c, we are decreasing. And a reminder that at b, you are neither increasing nor decreasing technically, because you are switching from those 2 points there. Also notice at b, if I were to draw a tangent line, I would have a horizontal tangent line here. My slope of that tangent line would therefore be 0. So how we can use derivatives to figure out if a function should be increasing or decreasing is by looking if f prime is positive or negative. If f prime is positive, that means all of our slopes of tangent lines would be positive, and therefore our function would be increasing on the interval where f prime is positive. If f prime is negative, that means slopes of all tangent lines would be negative, and f prime would be decreasing on that interval. So if I go back up to my graph here, if I take a look at where my tangent lines would be, on the blue portion, any tangent lines I draw would have positive slopes. On the red portion, any tangent lines that I draw here would have negative slopes. Okay. So if I look at the graph below, this is f prime of x that is shown. Okay. We want to know where is f increasing or decreasing. So f would be increasing if f prime is positive, and f is going to be decreasing if f prime is negative. Now a reminder here, this is the graph of f prime. So the question is, where is f prime positive versus negative? Well, f prime would be positive here, where our y values are positive, and f prime would be negative here, where our y values are negative. At 2 and at 4, we are neither positive nor negative. At 2 and 4, f prime is equal to 0. That means that we are neither increasing nor decreasing at these two locations. So if f prime is greater than 0 from 2 to 4, then f is increasing from 2 to 4. Notice how I'm not including 2 or 4, and that's because f prime is not positive at 2 or 4. F prime is equal to 0 at 2 and 4. For less than 0, we would be less than 0 from 0 to 2, including 0, that endpoint there. It is negative at 0, but not negative at 2. And also from 4 to 5. Again, it is negative at 5, but not at 4. So we're again not including 2 or 4, but we will include those endpoints because those endpoints here we are actually negative. Okay. Then this means that f of x, our original function, would be decreasing from 0 to 2 and 4 to 5, including 0 and 5, but not including 2 and 4. Okay. Now we can also use our first derivative, or f prime, to figure out where somebody has a maximum or minimum. Okay? A local maximum occurs at some value x is c if f prime is 0 or does not exist, and f prime changes from positive to negative at x equals c. So remember that we had our critical number test where we looked for where does f prime equal 0 or does not exist. And we said that that could be where we also have a maximum or minimum. We will specifically have a maximum if f prime changes from positive to negative at that x value, in addition to equaling 0 or not existing. So if I think about what a maximum looks like on a graph, it looks something like this. And at that maximum here, I would have that f prime is equal to 0. Now to the left of that maximum, I would have here that any tangent lines I draw, I would have that f prime is positive. And on the left or right-hand side, any tangent lines that I draw, f prime would be negative. So you can see that I would change from positive tangent line slopes to negative tangent line slopes after I switch from my increasing side to my decreasing side at that maximum. The opposite is true for our minimum. Again, if f prime is 0 or does not exist, and f prime changes from negative to positive. Again, if I take a look at where my f prime would be 0 at that minimum, to the left of the minimum, I would have all these tangent lines that have negative slopes. And to the right of the minimum, I would have all these tangent lines that have positive slopes. So at that minimum value, my f prime is going to change from negative to positive. If we have f prime equals c, f prime of c equals 0 or does not exist, but we don't change signs, we do not have a local maximum or minimum. And an example of where that might happen would be something like this guy here. At this point, I have f prime is equal to 0, but any tangent lines that I draw anywhere on either side of this value are going to be positive. So I do not have a local max or min. So in addition to having f prime of c equals 0 does not exist, we also have to have a change in sign of f prime to determine if we have a local maximum or minimum at that value. The other thing we can determine using derivatives is concavity. Okay? So a graph is considered concave up if it lies above its tangent lines. So this graph here is concave up. Think of it like a bowl of soup holding your soup and not spilling. If I draw tangent lines here, anywhere I would be able to draw a tangent line would be underneath that curve. The graph is concave down if it is below its tangent line. So think about this as like emptying your bowl of soup. So again, if I draw tangent lines, anywhere I draw them, my curve is going to be underneath those tangent lines. A graph is considered concave up and increasing if you increase from left to right, so your y values get bigger from left to right, but also your tangent lines lie below the curve. Okay? In this case, our f prime would be positive. If we were concave up and decreasing, this means our tangent line still is below the curve. However, we would have a negative slope for that because I would be decreasing in y values as I go from left to right. Concave down and increasing means that my tangent line will lie above the curve, but my y values will increase as I go from left to right. And if I was concave down and decreasing, that means again, my tangent line will lie above the curve, but my y values will decrease from left to right. So f of x is concave up when f prime is increasing here, you'll see. Okay. We have a concave down and increasing if we have our tangent line lying below the curve. Now, when we're looking for concavity, we're going to look at f double prime. Okay, f double prime being positive means f is concave up on that interval. F prime would also be increasing. F double prime is negative on an interval, then f prime is concave down on that interval, and f prime will be decreasing. Points of inflection. are where you have a point on a curve such that f double prime equals 0 or does not exist, and there is also a change in concavity. Okay, so f must be continuous at that point, and the curve is going to change from concave upward to concave downward or concave downward to concave upward. So here would be a point P where we have a change in inflection. Here, these would be concave up, and here these would be concave down. That's because if I were to draw tangent lines on the concave up portions, my tangent lines would lie below the curve. On the concave down portions, my tangent lines would lie above the curve. Okay. So inflection points occur when f double prime equals 0 or does not exist, and there is a change in concavity. It is possible that f double prime of c equals 0 does not exist, but there is no change in concavity, in which case then this is not an inflection point. An example would be something like this. Okay? If I think f of x is equal to x to the power of 4, f prime of x would be 4x cubed, and f double prime of x would be 12x squared. Now, f double prime of x would equal 0 at x equals 0. So I would think this should be my inflection point. However, if I look here, I can see that this entire graph is concave up. Anywhere I draw my tangent lines, they're going to lie below the curve. So there's no change in concavity. At x equals 0, and therefore x equals 0 is not an inflection point. Okay. Now we can also use second derivatives to find maximums or minimums. Okay. And that is if f prime of c is equal to 0, instead of testing to see if f prime changes direction, we can test for concavity. If I have something that is concave down, meaning f double prime is negative, and f prime of c equals 0 at a specific point, that must be a local maximum. So if you take a look at this graph, if this is a graph of f, if you think about this, f prime of c would equal 0 here. But also this graph is concave down, and we can tell by looking at this, this is a maximum. Similarly, a minimum would happen if f prime of c equals 0, and the graph is concave up. Okay. If f prime of c equals 0 and f double prime equals 0, then the second derivative test is inconclusive and we can't use it. We would use the first derivative test instead, which is where we're going to take a look at the changing sign of f prime. Okay. So we have two ways we can find if something is a maximum or minimum. Looking just at f prime, where does f prime equal 0 or not exist, and changing signs of f prime. Other one is where does f prime equal 0, and at that point, are we concave up or concave down? So let's try some questions using all this information. Okay. This here is a graph of f. Okay. And our first question is, where is f increasing? So we know increasing happens when our subsequent y values are larger than previous as I move from left to right. So increasing would happen from here to here and from here to here. Now I wouldn't be including any of the internal points, so I do include 0, but I'd go up to 2 and not include 2. And then I'd start at 4 but not include 4 and go up to 5. My decreasing would be from 2 to 4, but not including either of those. Now the question is, where is this thing concave up? So it's going to be concave up when I would draw tangent lines that would lie below the curve. So where does it look like it's an upward facing bowl basically? So concave up I can see would happen from about here to here, and then from about here to here. Okay, that would be up. So I'm going to say from 0 to 1, and from about 3 to 5. Now concave down would be in between those. Where does it look like I'm emptying my bowl of soup? Okay. And this would be from 1 to 3. Again, not including 1 or 3. I'm neither concave up nor concave down at those points. Now the next one's asking, where do I have a local maximum? So where does it look like I have a high point relative to the points around? Well, hopefully we can see that x equals 2 would be 1. Okay, that's actually my absolute maximum as well. And then hopefully we can also see that the point at x equals 5 is higher than the surrounding points. So that one is also local. Okay. Local minimum, what is minimum compared to the points around it? This would be 0 and 4. And 4 also looks like it is probably also our absolute. We weren't asked for that, but we can include that here. And then next is, where do we have an inflection point? So inflection points are changes in concavity. So we changed concavity at 1 and at about 3. So that would be my inflection point. If I went too fast there for you, you're welcome to scroll backwards. Now we're going to next look at, what if I gave you the graph of f prime instead of f? Okay. So the original function is what we're being asked about, but I'm being given the graph of f prime. So I don't actually have the graph of my function here. Okay. So now I'm going to be looking at this as if it's f. So f would be increasing if f prime is positive. So where is my graph here of f prime positive? It's positive right here. So this would be 1 to 3. Again, not including 1 and not including 3. Where would I be decreasing? I am decreasing if f prime is negative. Where is f prime negative? Right here and right here. So this would be from 0 to 1, not including 1, but including 0. And from 3 to 5, not including 3, but including 5. 5, the point there is just slightly below 0. Where are we concave up? We're going to be concave up if f double prime is greater than 0. So we need to take a look here and say, okay, if I were to draw tangent lines to f prime, tangent lines to f prime would be my f double prime. And where could I draw tangent lines here that would have positive slopes, making f double prime positive? Well, all these places here, if I were to draw tangent lines, these would all have positive slopes. So this would be from 0 to 2 and from 4 to 5. Now, concave down would be, where would f double prime be less than 0? Or if I drew tangent lines to my tangent graph, that's derivatives of my derivative, which would be f double prime. If I drew those tangent lines on this graph of f prime, where would I have slopes that are negative? And that would be from 2 to 4. Now the next question is asking us, where does x have a local maximum? So I know that x has a local maximum if f prime of x equals 0 and changes or does not exist and changes from positive to negative. So the question is, where here do I have f prime equals 0? So f prime equals 0 here and here. And where does it change from positive to negative? Well, that happens at 3. F is going to have a local minimum if f prime of x equals 0 or does not exist and changes from negative to positive. And if we look at our graph, where do I have f prime equals 0? What was that, 1 and 3? Where do I change from negative to positive? Negative to positive. So that was at x equals 1. The other way I can look at it is f prime of x equals 0. And for a maximum, f is double prime is negative, or I'm concave down. And for a minimum, F double prime is positive or I'm concave up. So I could have compared to these two as well and used these to help me for my maximum and minimum. That would have worked instead of looking from the changes. Inflection points, this is where F double prime equals 0 or does not exist, and change in concavity. So if I take a look at my graph, where would I have F double prime equals 0? So my derivatives to this graph, since this is F prime, my derivatives are F double prime. Where does it equal 0? Well, it would equal 0 here and here. And possibly here, we don't really know because we don't know what's happening on the other side of this. And the question is, where am I changing concavity? Well, here I went from positive to negative slopes, and here I went from negative to positive slopes. So I'm actually changing concavity at both 2 and 4. And this is happening at x equals 2 and 4. Oops. And that is all for this section. So some practice questions there you can try.